All right, guys, in this video, we are going to be comparing the three functions that we have reviewed in Algebra 1. We talked about linear functions, quadratic functions, and exponential functions. Let's talk about the main thing about each one. In linear function, you're going to have an equation that is going to have an x in that equation, but it's not going to have an exponent. As shown in these examples right here, you have y equals 5x plus 1. So we know that this looks very similar to y equals mx plus b. Y equals mx plus b. Y equals 1/2 x. 2x plus 3y equals 6. You see that you have variables, but you don't have an exponent, but you do have a variable x. Let me move that right there. I'm sorry. You do have a variable x, and so that's the x is what makes it linear. Now, what makes quadratic quadratic is going to be that squared. X squared, that is what makes it quadratic. If you have a square in the problem, you have a quadratic function. If you take that square away, you're going to be right back at a linear function. So let's look at exponential. Instead of it being a x squared for your exponent, for exponential, you're going to have an x in the exponent. That's what makes it exponential. Your exponent is now going to be a x. It's going to be the variable. It's going to be the thing that can possibly change. It's going to be the thing that can possibly change. So look at these examples at the bottom, 1 through 4. Pause this video and see if you can tell which one is a linear, quadratic, or exponential. All right, let's look at number 1. It says y equals 6 to the x power plus 3. Well, we have an exponent, and is the exponent a number or a variable? Well, it's a variable. So since it's a variable, we know that we have an exponential function. Exponential function. Remember, quadratic is only if it's x squared. So let's look at this next one. Y equals 7x squared plus 5x minus 2. Since we have that x squared, we know that it's going to be quadratic. Let's look at this next one. 9x plus 3 equals y. No exponent. So since we don't have an exponent at all, we know that we just have a variable x. That one is going to be linear. Let's look at this one. 4 raised to the 2x equals 8 plus y. You may be quick to say, oh, that's quadratic because you see the 4, then you see the little 2 up there. But what's paired with that 2? You have an x. If your variable x is in the exponent, it will be considered exponential. Let's move on here. Let's look at our three type of functions on a graph. We know that a linear function will make a straight line. A quadratic function makes a parabola. And then an exponential function either shows growth or decay. So it rises or falls quickly in one direction. So look at these graphs down here at the bottom. A, is it linear, quadratic, or exponential? We know that it's going to be quadratic because a quadratic function makes a parabola. It makes a parabola, and that's what this graph is right here. It is a parabola. Look at B. We have a scatter plot graph right here. We don't really deal with too many of those in Algebra 1, but it's still very important to know what it is. Have our x-axis right here, our y-axis right here. So look at this graph. Is it going to be a linear? Is it making a straight line or a parabola, or is it falling or rising in one direction? Well, it's definitely falling in one direction. So we're going to have an exponential function. Exponential function. Look at C. It's making a straight line. You know, when you have a straight line, you're going to have a linear function. The answer was in the word linear function. Let's move on here. Let's go on to this one right here. Now, we're going to be looking at tables here. We're going to be looking at tables. For a linear function, you're never going to see the same y value twice. And the reason why you're not going to see the same y value twice is because you're trying to make a straight line. You're trying to make a straight line. If you do, you won't have a straight line. You will not have one. Now, I'm going to make a note right here. We're going to be finding the equation for each type of function. And like I said, the steps stay the exact same. Let's write the steps on how to find, let's write that down. How to find equation given a table. Let's write those steps down right here. You are going to hit stat. Number 1, hit stat. Number 2, enter for edit. Enter for edit. If I'm not mistaken, this was included in your Marquez this week as well. Number 1, stat. Number 2, enter for edit. Number 3, you're going to put your x values in L1. And you're going to put your y values in L2. Then you're going to hit stat again. You are going to arrow over the calc. Arrow over the calc. And this is where I say the only thing that's going to change in each type of function is going to be the selection that you hit. You're either going to hit number 4, number 5, or you're going to hit 0. Or you are going to hit 0. So I'm going to go back on this side right here. So for linear, you're going to hit option 4 for line reg. Line reg. And it's going to, the way you're going to write your equation is going to be, let's write it right here. Y equals mx plus b, where they give you an m and a b. And in the calculator, instead of it being denoted as m, it will be denoted as a. It's going to give you an a and a b. For quadratic, you're going to hit option 5. Option 5 for quad reg. Quad reg. It's going to give you a B, and a C. And be y equals, you're going to write it in this form. Y equals ax squared plus bx plus c, where you only have to replace the variables a, b, and c. Exponential, you're going to hit the option 0 for exp reg. And you're going to fill in your a and your b. And you're going to write that in the form y equals a, b to the power of x. To the power of x. Okay? So with that being said, let's go ahead here and let's look at a linear. Let's look at this first one. Let's look at a linear. So if you go to your calculator here, and let's see, who can tell me, of course you're not going to tell me this is a video, but who can tell me, how do you reset your calculator? If you have stuff keyed in already, second, plus sign 712. Now everything in this calculator is clear, so I can just go ahead and click on stat, and I'm going to do my steps that I have, that I've written down right here. I'm going to hit stat, and I'm going to hit enter for edit. I'm going to hit enter for edit, and then I'm going to put in my values. X in L1 and Y in L2. Got to go back and look at my table for linear. We're doing the linear one right now. I'm going to make a note. We're doing linear right now. So I'm going to put in my X values, which is -1, 0, and 2. So -1, 0, and 2, and 1. I'm sorry, I left out 1. Got to make sure we match these numbers up now. So I have -1 is going to be paired with -1 for my Y. 0 is paired with 1. 0, that is right? Yeah, 0 is paired with 1. 1 is going to be paired with 3, and then 2 is paired with 5. So 2 is paired with 5, and then 1 is paired with 3. Okay, I'm going to hit stat again according to my steps. Go over to calc. I'm going to hit the option 4 because we're working with a linear function here. And I'm going to hit enter 5 times. It's going to give me an A and a B. It's going to give me an A and a B, so I can write down my A and my B, which is going to be 2 and 1. And now I can write my equation. Because remember I said in the calculator, instead of M, it's going to say A. So I have Y equals 2x plus 1. 2x plus 1. And now I have written it. And now I can go over here and I'm going to graph it now. Let's graph it. Let's graph it by hand. Let's graph it. We should get a straight line because remember, working with a linear function, so we're going to have a straight line. So I have a y-intercept of 1. Remember, the number that does not have a variable next to it, that's going to be, did not mean to make that big. That's going to be your y-intercept. So I'm going to put a point at 1 on the y-axis right here. And then I have a rise of 2 and a run of 1 because my slope is 2. So I'm going to go up 2, rise, and run 1. I'm going to rise 2, run 1. Rise 2, run 1. You can keep doing this, or we can just go ahead and we can draw our graph. That was not the greatest graph, but this is what the graph of y equals 2x plus 1 would look like. All right, let's look at this quadratic one here. Let's look at this quadratic one right here, and we have this table which is going to be -2, -1, 0, 1, and 2 for our x. So we are going to go back to our calculator here. I like to just clear the calculator out so I don't have to go and do all of the clearing out once I get to stat. But I'm going to go to stat and I'm going to hit number 1 for edit. And I'm going to put in my table. -2, -2, -1, 0, -1, 0, 1, and 2. I'm going to go over to my Y side and I'm going to put in 1, 0, 1, 4, and 9. 1, 0, 1, 4, and 9. Okay, I'm going to go to stat again, over to calc. I'm going to hit 5 this time because it's a quadratic function. Enter 5 times. It's going to give me an A, a B, and a C. So for that A, I have 1. For B, I have 2. And for C, I have 1. Now I'm ready to write my equation, ready to write my function. Y equals 1x squared. Do I have to write that 1? I don't. I don't have to write that 1. So instead of writing that 1, I can just do x squared plus 2x plus 1. Again, y-intercept, the number that does not have a variable next to it. So I'm going to go ahead and I can put a point on my y-intercept, which is going to be a positive 1, which is going to be a positive 1. So I'm going to go to 0 and I'm going to go to 1 and I'm going to put a point right there. Now I'm just going to plot the rest of these points in my table right here. -2, 1, -2, 1, put a point there. -1, 0, -1, 0, put a point here. That's my x-intercept because the y is 0. So that's my x-intercept. Then I'm going to put a point at 1, 4. I'm going to put a point at 1, 4. Go over to 1, up 4. And then I'm going to put a point at 2, 9. Over 2, 2, and then up 9. Now I'm going to draw my graph. Again, not going to be the scale, but just trying to give you an idea of how you graph by hand if you didn't have a calculator with you. You can see the graph, not to scale, but definitely makes a parabola, definitely a quadratic function. Let's look at the last one here, which is going to be exponential functions. Again, if I go to my calculator here, I'm going to do the same thing because I hate having to clear out everything in that table. So I'm just going to reset my calculator. Then I'm going to go to stat. I'm going to hit enter for edit, and I'm going to put in my table 0, 1, 2, 3, and 4. So 0, 1, 2, 3, 4. Go over to L2 for my y's, and I have 1, 2, 4, 8, 16. Remember, when you're dealing with exponential, your y's always, it doubles. 1, 2, 4, 8, and 16. 8 and 16. I'm going to hit stat, over to calc. This time is 0 for EXP-reg. I'm going to hit enter 5 times. And it's going to give me an A and a B. That A and B is going to be 1 and 2. 1 and 2. And so now I can write my equation here. Remember, whenever you write your equation, y equals 1, 2 to the x power looks like 12 to the x power. Don't forget to put parentheses around your b. Do I have to write that 1? 1 times anything is just that anything. So technically, I don't have to write that 1. So this equation, this function for this table would just be y equals 2 to the x power. Let's graph it here. We have 0, 1, so we have a y-intercept of 1. Let's make a point here. 0, 1, I'm going to put a point right here. 1, 2, go over to 1, up 2, going to put a point there. 2, 4, right here, go up to 4. 3, 8, start at 3 on the x-axis, go up to 8. And then 4 and 16, I'm going to ballpark that 16. Go over to 4, I'm going to go all the way up. Let's just say 16 is right here. And then I'm going to draw my graph, going to connect it together. And I see that as x increase, my y is going to rapidly increase. It's going to continue to go on and on and on.